So far in our little mini unit that we've been doing, we've done some work with right triangle trigonometry, which is stuff that you've done before in geometry. But now we're going to move into the things that are new, simplifying trigonometric expressions, where we're going to be taking some expressions that have sine, cosine, secant, cotangent, all of those different things, and try to simplify them. Now, foundationally, this is really, really important when you get to calculus because you'll need to know how to simplify some of these expressions. So we're getting a little bit of a taste how to do that now. You'll do a lot more of this next year in pre-calc though too. Before we get started though, let's refresh our memory on some of those trig expressions and how different expressions are related to each other. So remember that secant is the reciprocal of cosine. Cosecant is the reciprocal of sine. And cotangent is the reciprocal of tangent. Now, if you look at how I'm writing this, notice that I always say the secant of theta, the cosine of theta, the sine of theta. Theta is representing an angle, and we have to have that theta here as well. We can't just say cosecant equals 1 over sine. If I don't have that theta, mathematically it's not correct, because you can't have the cosine of nothing. It has to be a cosine of an angle. In addition to these reciprocal functions, we also learned that the tangent is the sine over cosine. The sine of an angle is the tangent of an angle is its sine over its cosine. And related to that, the cotangent, since it's the reciprocal of tangent, would be cosine over sine. So these are all identities that we have used before. Now, there is one extra relationship that's called the Pythagorean identity. And you'll learn more in pre-calc next year why this is actually called the Pythagorean identity. But the identity is that sine squared of an angle plus its cosine squared equals 1. So really this comes from the Pythagorean theorem, and that's as far in depth as I'm going to go with this now. That sine squared theta plus cosine squared theta equals 1. So as we're simplifying expressions, if we ever see sine squared plus cosine squared, we can know that that's really just 1, and use that as a really good tool to help us simplify. All right, moving into examples with simplifying trig expressions. We're going to simplify each expression, and I'm going to do 2 examples here. Watch them both. The first one's quite a bit easier than the second one. So, simplify each expression. Part A, we are going to simplify the secant of theta times the cotangent of theta. And we just basically need to start simplifying different ways using any of these identities up here to see what we can come up with. Really, when we're simplifying, that's basically what we want to do. So just looking at this, I know secant is the reciprocal of cosine. So I'm going to replace this secant theta with 1 over cosine theta. And I also know the cotangent is cosine over sine. Might as well deal with that also. And now I have a fraction times a fraction, so we might as well multiply those. Multiply the numerators. That's cosine of theta. Multiply the denominators. That's cosine theta, sine theta. Oh, and that works out really nicely because these cosines are going to cancel out to give us 1 over sine theta, and 1 over sine is cosecant, because cosecant is the reciprocal of sine. So that worked out pretty easily. Really, when you're simplifying an expression, we just have to start with something, replace secant with what we know secant is, replace cotangent with what we know cotangent is, and hopefully something will work. Let's do a second example, simplifying. This example is definitely more complicated. We are going to use cosecant squared theta minus cotangent squared theta. Alright, if I didn't have the squared here, cosecant is just 1 over sine. Cosecant squared is 1 over sine squared. And then cotangent, again, if I didn't have that squared, cotangent's just cosine over sine. Since I have cotangent squared here, that's cosine squared over sine squared. Okay, now I'm actually going to write this. I'm going to take this line, move it down here, but kind of use 2 lines. So hopefully this will be a little bit easier to follow along. Okay, well now looking at what I have, we have one fraction minus another fraction, and to subtract fractions, because we might as well try it and see what happens. To subtract fractions, we need a common denominator. Fortunately, we already have that. So we can just subtract the top. We get 1 minus cosine squared theta over, keep the denominator the way it is, sine squared theta. Okay, now let's look at what we have here. Looking at the top, I notice that we have a 1 minus cosine squared, and that kind of jogs my memory that maybe it has something to do with the Pythagorean identity. Okay, I'm going to go up here for a second. I'm going to switch my colors. The Pythagorean identity is sine squared theta plus cosine squared theta equals 1. Well, we have 1 minus cosine squared theta. If I look at my Pythagorean identity, if I subtracted cosine squared theta from each side, that would give me sine squared theta equals 1 minus cosine squared. Oh, so now I can really just replace this 1 minus cosine squared that I have in my problem with sine squared theta. See if I can get that to focus a little bit better. There, that's a little bit better. So I'm replacing this 1 minus cosine squared with sine squared. Over sine squared theta. So all of that cancels out, and my final answer is 1. How crazy is that? So we started off with cosecant squared minus cotangent squared, and after all that work, it's just 1. Now, if you didn't recognize this 1 minus cosine squared was another variation of the Pythagorean identity, we could get there if you just kind of looked at this 1 minus cosine squared. We could have gotten there if we would have gotten a common denominator and a bunch of stuff there. Just gets a lot more complicated. So it's a lot easier if you recognize the Pythagorean identity.